Hey, how's it going, everyone? Just going to do a video doing a bit of commentary on a hangout last night on Ranty's channel with a few flat earthers. I joined a little bit later, and then this guy named Ruhif, who's a ball earther. And so he jumps on, and then there's Ranty and then a couple others kind of holding his feet to the fire about this image, which is, it's a pretty powerful result, observation. The quote smoking gun, in discussions lately in ball earth and flat earth. And so this is a very, very difficult thing to explain on the ball earth. And Ruhif will tell us exactly what is needed, to understand this kind of an observation on a ball earth. And, I just want to point out the subtlety, I guess, of what he's saying, in case it is subtle for some people. But basically, these are two, as you can see, like oil platforms in, I believe, off the coast of California. And one of them, I think the close one is about 6 miles away, and then the further one is 9 miles away. And the incredible thing about this is that the observation is taken at 1 foot off the ground, like just barely off the ground. This is a video, but this is just a still capture. And so the alarming thing here for people who are ball earthers is that you can very clearly see that the water is still visible even beyond the furthest platform. And so that horizon should never extend beyond the further platform, not even the closer one, because according to the Earth Curve calculator, it should be, I believe, around like 1 or 2 miles, the horizon. And then the Earth would start curving afterwards. And so the fact that the horizon is so far in the distance is indicative of a flat Earth. Just again, if you picture a hallway, if you just think of any long hallway that is flat, straight, level, all those things are the same. You would just keep seeing the ground, all as far as a person can see, and there's no like drop off or anything like that, no limited visibility. And so that's what we're seeing here, is essentially just a very, very long, flat, expanse of water. And so he will again tell us, like I said, what is needed for this to work, quote, work on the ball earth. There's no way that, first of all, even just seeing flat water for 6 to 9 miles should be compelling enough, but to see it extend beyond these two platforms is pretty close to a globe killer. And the only thing that will rescue it is what Ruhif will share here. And I'll just point out how absurd that is, but let's listen in.
Always throw the old Neil deGrasse Tyson, you don't see curvature, but there's no mathematics behind that statement.
Well, he's saying that because he's covering his own back there, because he knows we're not finding curvature, and we're not going to be finding curvature. He knows this is not going to happen. So consequently, he's saying, you won't see it even from 120,000 feet. He's covering his own back there. It's like, because no one's going to be at 120,000 feet. Only the very...
He's wrong about that, by the way.
Sorry?
Neil deGrasse Tyson is wrong that you cannot see curvature from 120,000 feet.
So first point, this is also kind of relevant, is that we have ball earthers telling us a whole bunch of different stories. Neil deGrasse Tyson, the ball earth high priest, is telling us one thing about visibility at a certain height, and then now Ruhif is saying he's wrong about it. Apparently this is like many, many years of, quote, settled science. They don't know what they're talking about. It's scary. I mean, it would be, I don't know what the equivalent would be, but it's just somebody who's well known in a particular field, like a religious person, for example, to put a spiritual context behind it, saying one thing about God, and then having his congregation say something different, but they're all sitting in the same, quote, church. And so that's what's happening here, because modern day technology has advanced to where cameras and other optical devices are seeing things, in this case, a very, very distant horizon that does not make sense on the ball earth. And so even with feet on the ground, we're seeing things that we shouldn't, like again, a horizon many, many miles away. And then the same thing that's happening with people in balloons and planes and stuff like that. not seeing curvature. So there's infighting amongst the ballers, which is a sign of the fact that they're lying.
Telling.
I've been
Okay.
Yes, yeah.
So Ruhif, on screen we have Quantum Eraser's Black Swan image.
Where? I can't see your screen. Hold on.
It's
Is it
on
on
the
Skype?
on the watch page if you've got it
Oh,
open.
all right.
Is that
I do,
QE's
it'll
image?
take a while.
The rigs? Is the rigs?
That's the rigs with the horizon beyond the second rig. Because you asked about where the horizon should be on a flat plane, and I would just say it's all down to the optics of the day. You know, I mean, you can't.
Yes.
You know, that's essentially it. Whereas you have a defined horizon, and this image kind of like goes against that defined horizon, wouldn't you say?
Do I think there are strong refraction events happening here today? Yes. And I showed you.
So he changes the question to just what he has to say now is that these distortions, these little distortions that he's about to point out, are indicative of the fact that these two platforms are actually being bent up over a curve. And I'll give you a visual of that with another Flat Earth channel, Sleeping Warrior, in a second. But that's what he has to say, is that, again, this is what ballers have to do in many, many instances, not just this one, that these images or these actual platforms are just images, representations of the actual structure being loomed up or curved over Earth curves so we can see them. And that's why they're placed in front of the horizon, because of these very, very strong refraction events that he pretty much has no choice but to cite, as the reason why we're seeing this kind of an effect. And so the thing that's scary is that if you look at both of these platforms, they look fairly, visible. You can see detail and all that. The one that's further, there is a little bit of, distortion, in this arm that's sticking out. You can see that that's not the way it would be in quote real life physically, and you see a little bit there. But for the most part, the structure is pretty much intact. This one is very, very clear. The one that's about, I think, 6 miles away. And so not surprising that the one further away would have more distortion. And so, but that is his citation for this excessive and what he's about to claim infinite refraction that is creating this perfect sort of stars aligning in order to see these two things over Earth curve. And so I'm just going to clarify exactly what that assumption means sort of mathematically for ball earthers and for us, and how for us it's a much more obvious and physical explanation for what we're seeing. But ballers have to resort to, again, what they call looming, or what he's about to say, infinite refraction, where light is bending around a curve the most that it's able to.
Images from another one of these BMLSB 69's videos this morning, showing the difference between strong refraction and a normal day.
Refraction.
Just going to fast forward it a bit to where he actually
Flare boom, don't
makes
you?
the kind of
It's for.
insane
Oh, wait a minute.
statement.
Let's just clarify this. The refractive is 1.3.
Standard refraction 1.3, yes.
Yeah. So what refraction
That's
is
based
this?
that's based on a radius.
This
You
is
guys, you dickheads can
700%
quote me,
more.
right? You guys, you fuckwits can quote me on this. This is greater than infinite refraction.
Oh, so the
I don't even know what to say to that. We were all like stunned. Yeah, it's just crazy. Like, we can even see in the chat, people are like questioning this guy's sanity. He's like, I thought Ruhif was a date rape drug, and it just sounds like these ballers just sound like they're out of their mind. Like they're obviously lying. They're shills. Like, a lot of them work for the government directly. But he's saying, first of all, let's listen to that again.
This is greater than infinite refraction.
First of all, somebody saying greater than infinite, that doesn't even make sense. So these people are lost. But let's just, say that maybe he's just saying that to exaggerate or to get his point across. But infinite refraction is this case where these rays are snug to the Earth and tightly coupled to the Earth and shooting over Earth curve to present these images to us. And so they don't believe that these are physical. if we were to shoot like a straight bullet to these things, they don't believe that that's the actual physical structure. You know, in order to reach the actual physical structure, these people who are citing looming and infinite refraction say that a bullet or an object would need to be curved in order to actually hit the physical platforms. And so this is what they have to do. And this is not the only instance. There's many of them where they will cite this infinite refraction. I believe Rumpus refers to it as a K value of 0. It's just these perfect, amazing conditions where the ball Earth appears flat. And so that's why we're able to see it again with infinite refraction. So
so the infinite slider.
refraction?
refraction.
Excuse me?
Infinite over 6R. Infinite over 6R. Quote me on that.
No such thing.
So all the flat earthers were obviously like, this guy's out of his mind. And I'll explain where the infinite over 6, what he's referencing there. And so that is a reference to this notion here on some of these curve calculator websites. This one's Metabunk. They just use an approximation for refraction as 7 over 6R. They basically kind of help their own model and say, like, you know, we can, you know, based on the size and geometry of the Earth, rays are going to, you know, shoot up, you know, over the Earth, and then by this amount, you know, they get this much, quote, help over Earth curve. And so this is the default. Like he's saying, it could be infinite, it could be much more than this, and then there could be other instances where it's much less. So here, this is just an approximation, the sort of midpoint. And so when he says infinite over 6, he's replacing the 7, you know, and a bit tongue-in-cheek, because you don't need to divide infinite by 6, but he's basically manipulating this variable, 7 over 6, and saying that that is the variable that is giving us, you know, this this result, you know, is that's why these two platforms appear in front of the horizon, and the horizon is very, very far in the distance, is that he's basically pumping this number up to infinity and saying that this is a very, very special case, and then he goes to the insane claim of saying it's greater than infinite. But this is where it's kind of cool. We're now boiling down our technical differences with the ball earthers to very, very granular and binary cases where the ball earthers will take this variable and pump that to infinity, but we will leave that alone. Let's say that that is a fairly good approximation for refraction. We would, flat earthers, take this R and make it infinity. And so when you make R infinity, if you just look up any picture of like a sphere, if you take this radius, you know, just imagine, you know, this as their visual, their understanding, their religion really of our Earth. You pump this R value up to infinity. If you can visualize it, it just elongates this ball into this, you know, into a flat kind of disc, pancake kind of thing. Again, in the limit, if you were to fix the volume of this sphere and then pull it out, make the R infinity, then you get a flat surface. And so that's what we believe. You know, we believe that that this 7 over 6 is not going to infinity, which just whenever anybody invokes anything infinity, it's non-physical. You know, you can't have infinite refraction. Infinite is non-physical. It's a mathematical construct. And so this is where it's nice. We have a better position as flat earthers, is we just have to say R is infinity, and that is physical because that's a flat earth. And we see that in many, many examples, not just in this. And just common sense, we know that, you know, the Earth doesn't move and stuff. So we know the heliocentric model has major flaws. But, you know, flat earthers, we get to pick R to infinity and have a flat Earth and then have some maybe minimal amount of refraction, which will account for, you know, these little distortions here and there, but very cosmetic, very minor distortions. Nothing to tell somebody to go get crazy and start, you know, putting in infinite refraction or anything like that. So this is what it boils down to. And I would say for flat earthers, we have a very, very strong position technically now, and it literally boils down to these two variables where, first of all, the 7 over 6 is made up. Like it says here, it's an approximation. But let's entertain it for now. They're going to jack this thing up to infinity, which is crazy. And then we have the luxury of just being able to say, you know what, we see it because we live on a flat Earth. And your model may actually work sometimes in reflecting reality, but for this observation and many others, this R needs to be infinity, which is a flat Earth. And so once we've poked their model with one observation that doesn't make sense, like this one, and others where they've had to loom or refract their way heavily out of it, we as flat earthers, again, always just have the luxury of saying the Earth is flat, and then a minimal amount of refraction accounts for it. And then they have to say infinite refraction and then a fixed Earth radius. Here's what it looks like visually. And this is another flat earther or globe skeptic, Sleeping Warrior. He's going to go through another curve calculator and kind of show us visually what this looks like.
To make the point, if I make the zoom bigger, should make that target thing bigger. There we go. So all I'm doing there is changing the zoom so you guys can see it. Otherwise, I'm not going to make any changes other than the refraction. If your model states that refraction explains this, well, look, in your refraction bullshit slide.
So first off, just to set this up, this is the exact same pretty much as this, just maybe a more visual representation of Earth curve. And so this is a Walter Bislin curve calculator. I believe this one's Mick West for those numerology people. Mick West, MW is 33. This is Walter Bislin. WB is 32. 3 times 2 is 6. And this is just a more visual one of this text base. But again, Anthony is going to show us here, Sleeping Warrior, what they're assuming.
This is basically, we know that refractive effects occur at the horizon based on Fermat's principle, on the trajectory of light. Light does not follow a curved path. Just because you tell us it does in your model doesn't mean it does real world.
He brings up a good point. This is the first issue that just it's common sense. Light doesn't have an inherent intrinsic desire to curve. You know, it's only if the medium forces it to curve, and very rarely would those kind of situations happen where it curves perfectly around Earth or any curved structure. Its natural path is straight, you know, and then if it experiences different media, then it will do different things and bend and do wonky different things, just like, you know, the stuff that we see going on here. And so, you know, that's what it is. And so they're already starting off with a false premise that light has an intrinsic desire to curve.
Real world, light deviates from straight in all directions based on the time it takes for the light to traverse the path, according to Fermat's principle on the trajectory of light. It's minuscule. Now, you guys claim that refraction is all you need to explain it. Now, if I get the refraction thing and I fuck around with this and push it right to the extremes, then that matches your model in the sense that all you need is refraction. So
you can see when he pushed it over here, you know, you can see that the kind
extremes,
of variation.
Then
you know, if he has light refraction, then yeah, there are things that will be, quote, invisible or behind Earth curve, but when he pumps it up, you can see it brings
matches
it
your
into
model
the
in the
foreground.
sense that all you need is refraction. So what this does is, if we go to Pontchartrain, and we see that Pontchartrain is explained by sliding the slider all the way down here, because obviously Soundly's pylons and stuff at Pontchartrain, they're like this. So that must be crazy atmospheric refraction. But to argue it the other way as well means that you're just going to use the atmospheric refraction to counter it too. But look what happens. To get it to explain what we see.
So he's also referring to this this image as well, because it's been kind of a hot topic on debates. And so you can see what he's doing here. Here you can see the refraction is normalized, I believe, between -1 and 1. Let me make this bigger. Yeah, you can see that here it's 0.999. So you can see that whoever made this, they just normalized the refraction to be between -1 and 1. And so he pumps it up, you know, all the way till the end. And so that brings this structure, again, curious, EE for those people, that's 33 in numerology. I mean, all these people are on God's left-hand side. But they put their encoding everywhere, but we see 33. But yeah, so he pumps this thing up, and then that brings the structure into the foreground, and then puts this dark blue line behind it, you know, and puts the horizon past it. And so, which is exactly what we're seeing here. You know, 2 platforms and then the horizon. You can see it's beyond, it's past this one, which is 9 miles away. So you can see you can see water extending beyond this platform. And again, just be aware. You know, we can even see a little bit of detail with this, you know, flotation device. Just be aware, this is like a foot off the ground. So this is literally pretty much somebody laying on their belly, looking out and just seeing what we would see with flat water. And so, you know, that's what we're seeing, you know, 9-10 miles of flat water. And for the horizon to be behind these 2 platforms, we would need this refraction event pushed up, like Ruhif was saying, like huge, like maxed out. And so that's what they have to believe. You know, they have to explain these observations away with basically pumping this slider all the way to the top, whereas we as flat earthers have the luxury of being much more modest in our you know, understanding of how much refraction there is, and just it's just the flat Earth, you know. And then depending on the atmosphere, we'll be able to see varying amounts of detail, but nowhere in this image, with the very minor distortions that are happening here, would we think that that's reason to go and pump this refraction all the way to the top, you know. And if somebody were to just literally keep the camera still and average out the images, this would get corrected. You know, these little distortions would just get averaged out because they're just local to these 2 arms. You know, because again, for the entire structure, for the most part, is very, very clear. You know, we can see it, and this one is very clear. We can see a lot of detail, which means that, you know, the conditions are pretty good. And so this day would be a day where visibility is very, very good. I suspect it's cooler because that will make less of a temperature gradient from water up, and you know, that's why we can kind of see a lot of detail in both of these. And then that would actually limit the amount of distortion, and then that would actually motivate us to not have this red bar way over here. But that's with ballers. They have to look at an image that's fairly clean like this and say, wow, look at all the distortion, you know, there's so much. Whereas normal people will look at this and be like, there's very little. And so it has to be a flat Earth with a little distortion, not a curved Earth with infinite distortion. So that's really the heart of the matter. You know, that's the crux of it. You know, people are just going to take more and more of these images, and then on even clearer days, the horizon's going to be even further past platforms or boats or whatever in the distance. And so they're just going to run out of room. You know, they've already infinited out the refraction here. So let's say in another image down the road, these 2 platforms are double the distance away, but you still see the horizon in the background. They're going to run out of room to refract and loom, because again, he even said, we can quote him on this.
Infinite over 6R. Infinite over 6R. Quote me on that.
Okay, so he just said quote him on that. So, I mean, they're putting themselves in a corner, and he even said more than infinite. And so, like, he's stretching infinity. But, you know, that's the problem with a person who's a ball earther, is that, again, like I said, if these platforms were further out and then we see a similar effect of like the horizon past both of them, they're going to run out of refraction. Hope everyone's doing well. Bye.